Hello, today we will talk about the Matlab serial tutorial 2. The first function is the setup serial. All it will do is just initialize the serial port, and you can check it in the part 1 of the Matlab Arduino tutorial on YouTube. This section I already omitted from the original tutorial because this is a handshake function between the Arduino and the Matlab, and I don't use it. And why I don't use it, I will tell you later. So this is the setup serial. Moving next, after we got the serial port setup, we'll move to the read. We'll move to the calibration setup. We will go to the read accelerometer setup. In the read accelerometer, first I will flush out on the input. Why do I need to flush out on the input? Because you only want to read the fresh data. So if I don't flush it, I may read the old data in the buffer, and it may not reflect the correct current accelerometer. This may cause issue when the data rate is too low and you don't have the data right away, but it's okay for now. I just keep it a proof of concept. For the original tutorial on YouTube, it used a handshaking function where it was gonna send a character to the serial port, then the Arduino will send the current accelerometer values. So it is quite the same. Next, I will read the data from the serial port. You notice that the out.s is equal to s. For the tutorial on YouTube, you may not find this section because it is in the calibration function. They run the calibration function first before the read accelerometer. So that's why I already initialize. And after I read it, I will check whether the string that I read have the x value. Why? Because this is my format. This is my every accelerometer format. The value of x, value of y, then the value of z. So sometimes the buffer has some just half the value, for example, from y to z only. So it will reject this data. It will only read from x to z to the end. So I will read until I got the x and read to the end of line. Then I will, because this is a fixed format, so I can just pick this section from 2 to 6 for x, from 8 to 14 for y, and from 8 to 12 and 14 to 18 for z. This may cause problem when my data I got more than 1G, which the data may go below 10,000, but I don't think so. It should be fine because I only use the only use about 1G, so it should be fine. This is the offset, because when you read the accelerometer, you pass in the calibration coefficient. So it will take the offset from the calibration coefficient, and then it will take the value already read, so it minus the offset and divide by gain. The gain, what is the gain? If you read the calibrate function, you understand the gain better. It's actually the standard value for 1G. Not a standard, but the value after calibration for 1G. And last, because we have to pass out the value for the x, y, and z for this function, so we here we will after we do some multiply, we pass back to x, y, and z. Then I choose to display it. Next is the calibration function. In this calibration function, first you don't know what is the coefficient, so you initiate it at 0 and g equal to 1. Then actually you can see the video on YouTube from the Arduino Matlab, so you understand what are they doing here. Basically they want to measure the offset and the gain that I mentioned before, the value for standard x after calibrate. Then here I display out the values, and so it's complete. So next is the demo. Hello, so this is the demo. First I need to put it, because we start to set up the serial port first, so I need the COM port equal COM7. I copy this function. It will open the COM port. Oh, so look like something wrong. I need to close the okay, the serial port already closed. Try again. By the way, the close serial port is just a series of finding the open port and close it. Okay, we got something from the serial port. That's good. Next is we'll calibrate. Oh, I forgot. We have to take the S and the black out from the setup also, because otherwise we don't have the data for subsequent function. Okay, that's good. So you see it's the correct format. Next, I will calibrate. Let's see what do we need for calibrate. So calco equal to .s. Go. Okay, I put the accelerometer on flat surface. Okay. X point up. Y point up. Okay, done. So let's see what do we got here. We got the again the G for 1x, 1z, 1y is almost very clear near 49,000. It's clear here, from here, and from here. And the offset is around 3 point something. Okay. Next, we need to try to read values. But be careful. This one you will read the out.s instead of out. So we need to convert here. We convert the out equal to out.s equal to s. So copy here. Bam! That's good. I'm pointing up. Is correct. That's it. Thanks for watching.